Good morning, ABO fam. We are working on our math review today. We'll have a couple of videos to cover the entire math review quiz. We're going to start with metric conversions. I'm going to do number 3. We're starting with 0.25 centimeters. They have asked us to determine what that is in millimeters. Now remember, we're doing my doctor collects millimeters. That's going to put us in the proper order. In this scenario, we're at centimeters, 0.25 here. We are headed to the millimeter section, so we need to move our decimal to the right, and we're just moving one spot. So that means our decimal that's currently here in front of the 0.25 is going to sit right in the middle then, or an answer of 2.5 millimeters. So remember, draw out your conversion chart. Throw your original request on the chart, and then move the decimal the appropriate number of spots. If we had to convert this centimeter option into either decimeters or meters, we would need to move our decimal to the left. That would mean that we would be adding a 0, 1 0 if we are moving to the decimeters, or 2 zeros if we were moving to meters. So again, write out your conversion chart and then move your decimal the appropriate number of spots in the appropriate direction. All right, let's do a quick transposition just to make sure that we are on the same page here. Let's just go ahead and do number 5. So we're starting with a minus a half, minus a quarter at 80. Step 1 is combining our sphere and cylinder together. We do have 2 minuses in this case. I know this sounds silly, but we are going to use the calculator. We want to make sure that we aren't missing anything here. So we've got, oh, I'm missing my decimal. I got to slide this guy up a little bit here. So we've got 0.50 plus 0.25 equals 0.75. It's a minus because we're dealing with 2 minuses. Remember, same signs, we're just adding those together. Step 2 is changing the sign of the original cylinder. We're starting with a minus. We're going to switch that to a plus. Number stays the same. And then last but not least, we've got to change our axis by 90 degrees. Again, I'm going to grab the calculator. We're currently sitting at 80, which means that we need to add 90 to that. So 80 plus 90 equals 170. I know it sounds silly. However, one of the mistakes I see happen most often is in that part of the transposition process, that switch of 90 degrees. So we should have a minus 75 plus a quarter at 170. Let's go ahead and move on then to the reading only prescriptions. Now remember, with reading only, we're adding 100% of the add power to the sphere, and we're going to leave the number alone. We'll just go ahead and tackle number 9. So we are currently starting with a plus a quarter, minus 1. Let's fix that. Minus 1. At x is 45. And they've given us an add of 225. So reading only, we're using 100% of our add power. We're combining that with the sphere, and we've got 2 pluses. Grab that calculator again, just add in those 2 numbers together. So we've got 2.25 plus 0.25 gives us 250. So plus 250. Then our sill and axis just get pulled straight down. There's no change in astigmatism correction. That stays the same. I need that help whether I'm reading a road sign or a book. So our changed script should equal plus 250 minus 1 at 45. So reading script. We're going to do the intermediate prescription as well on this video. So this particular one, let's go ahead and do number 10. So we are -1 sphere in this case. Thanks, guys. Makes our life a little easier. We've got a 2 add. Now this time we're making an intermediate or a computer pair of glasses, which means that I'm going to be using 50% of my add power. So we need half of 2. Again, we're grabbing that calculator, just being safe. So we do 2.00 times 0.50, so 50%, equals a 1. So we've got +1, that is half of our add power. We're then combining that with the sphere. And if I have a +1 and a -1 added together, in this particular case, because they're opposing signs, we do 1 minus 1, because remember, when our signs are opposing, we're going to subtract the bigger from the smaller. In this particular case, they're both the same, so we end up with a 0. In the optical world, we would say then plano. So this particular patient for the computer actually would not need a prescription. Maybe a nice set of blue text would do the job. All right, so I'm going to wrap this video up with that intermediate prescription, and then go ahead and log into video 2 of our math review for power and requested meridian and horizontal prism.